Welcome back to the IRC Wall Bracing Calculator. This video is all about tall wall engineering. So the IRC limits, by default, wall heights to 10 feet. If you want to go anything taller than that, you need some sort of engineering analysis on that. According to ASCE 7, what is it called? The Wood Framer's Handbook, and NDS. So this calculator embedded in here is an engineering tool that can handle all of those calculations for you. And I'm going to walk you through how to use that. So let's say that over here in this little example building we have a hobby shop, and let's say we want taller walls here. Right now my default wall height, if I'm assigning wall bracing and I click here and I say that wall is 9 feet, right? So there it is, 9 feet. If I want to make this taller, say something like 14 feet, a little button shows up called Engineer Tall Wall. You click on that and it opens up all these other extra options that you'll need to fill out to perform the engineering calculation. And each one has this little bubble that'll tell you what it's talking about. So in this case, the roof span, this wall here, it's like saying what's the span if this is a load-bearing wall, what's the span that it's supporting. So I'm going to say that, from here to here, that distance would be 23 feet. I measured it before. The overhang, that's just that little bit there. It doesn't matter that much, but we'll say it's 1 foot. The roof pitch, we'll say it's 12 to 12. Stud spacing, that's fairly obvious. We'll say that the spacing is 16 inches. And then we have the size, species, and grade. Select is going to be hard to find. Let's try number 2. This one here, wall at an exterior corner. Well, by ASCE 7, load tables and whatnot, there's this phenomenon where, like, wind that's sort of wrapping around corners of the buildings, namely like this panel and this panel, those panels are going to be experiencing greater pressure, and so you need to design for that. I'm just going to do one of these walls here, so that wall is not at a corner. And now we're getting into loads that this wall supports. We'll say it supports 10 PSF dead load. There's nothing above this other than the roof, so no live load. We'll say that the roof live load is like 20 PSF. That would be like what people walking around and on it when they're building it. And some snow load, just to give it something here. Northern climate will give it some snow. So now when I've set up my defaults, right? Now if I click here and click here, these walls are now tall walls, right? Now I've just said they're this. Do they meet code? Well, that's where these switches here, down here, engineer tall walls, will let me know. So I click on that and, there's something about this that doesn't meet code. Let's find out. Right click. They have insufficient strength to stiffness by a factor of 0.59. All right, so I should try changing something about this. The size, the species, the grade. All right, let's try 2x6s instead. We'll make this one a 2x6 also. And reset that switch, run it. Hey, no issues were detected. Okay, so as long as I make this wall 2x6, it works. But now a caveat I want everybody to be clear on is that by making this wall taller, I've changed its aspect ratio, and that can affect its wall bracing, its lateral bracing strength. So this might be invalid now. Let's see. Okay, it's not. So no issues were detected. It's still good. But what if I made it, I don't know, 16 feet? Yeah, okay. So this wall is now 16 feet. It's too narrow. It's too narrow and tall to be used for wall bracing. It still might work Yeah, so it still works as an engineered tall wall. That means it's capable of handling the vertical load and like the wind load that's pushing at it, like making it bend in and out. But going back to this one, now it's no longer valid to handle the wall lateral load or the racking load. So I'll set that back to, well, actually no, I'll leave it here, and we'll see how this shows up in the report. So you know, you'd use this sort of method, design your building however you want. And when you're ready, let's see what the report looks like. The report will now have, because I'm using an engineered tall wall calculation, it's going to have some extra tables here. So this is the engineered tall wall summary, and there are 2 walls that I have designated like this. This is all engineering language stuff. If you're familiar with NDS, you know you should be in your happy place. If you're not, it probably just looks confusing. Here we have the ASCE 7 load combinations, and it's just doing engineering checks. So if the stress is less than 1, then you're okay. And one of these, oh yeah, no, these would both be okay, but remember, I made that one wall invalid. This wall here is it's too tall to count as lateral wall bracing. So it's possible that now brace wall line vertical 3 might have some problem, and it looks like it doesn't because it still has sufficient bracing. Yeah, so it's still good. Anyway, that's the gist of it. It should be enough to get you started.